Okay, so what I have here is a little tabletop demonstration of this granular sorting phenomena as it applies to the unexploded ordnance problem. So what we have here is a little acrylic box, and it's half filled with sand, and the sand is saturated with water. You see a little white ball down here at the bottom. That's actually Delrin plastic. Sitting proud up at the top is a steel ball, and of course it's sand in the middle here. Now, when you talk about the density of these different materials, Delrin is roughly half the density of sand, and the steel ball is more than twice the density of sand. And so what I'm going to do is I'm going to take this container and I'm going to start shaking it back and forth on the tabletop here. What I'm simulating is what waves would be doing to the seafloor as they pass overhead and rework the bottom. And so what you're going to see immediately is that the steel ball, which is more than twice as dense as the sand, is immediately going to bear. And you notice the plastic ball hasn't really moved anywhere yet. Right? And so I haven't been shaking it very hard. So I'm going to shake it a little harder now. I'm going to make the waves bigger. Right? So the waves are starting to break now. And as I shake it harder, what you'll see is that the plastic ball rises to the top. And the steel ball continues to sink. And this granular buoyancy phenomena is an irreversible process. So no matter how hard I keep shaking this, that plastic ball will never go back down, and the steel ball will never come back up to the top. Now, of course, I have a magnet that I use to bring the steel ball back up to the top to reset the demonstration. But this is the granular sorting phenomena that we think explains a large part of the munitions mobility problem.